welcome to the deep dive. Today we're getting into some really interesting sources.
Yeah, they connect food security and something called price elasticity.
Exactly. And for you listening, especially if you're, dealing with calculus in college right now.
We want to bridge these big economic ideas to your math studies, specifically things like differentiation and integration.
Right. So our mission, basically, is to figure out how these sources explain the link between food prices and supply changes.
And crucially, why the calculus you're learning is, well, actually the perfect tool to analyze it all.
It seems a bit surprising at first, doesn't it? Calculus and food prices. How do they connect?
Well, the sources mention this key phrase, the sensitivity of food price to supply changes. That's the starting point.
Okay, sensitivity. What does that mean in, plain English?
It's basically how much the price of food reacts, jumps up or down when the amount available changes.
So if there's suddenly less wheat, does the price shoot way up? Or just nudge a little?
Exactly. Is it a big reaction or a small one? That's the sensitivity we're talking about.
Got it. And, okay, the calculus connection. Differentiation. Why is that relevant here?
Because differentiation is all about measuring rates of change. Instantaneous change, really.
Wow.
Think of price, let's call it P, changing as supply, S, changes. Differentiation lets us find DPDS.
DPDS. The derivative of price with respect to supply.
Precisely. It gives you the exact rate that price is changing relative to supply at any specific point.
So that sensitivity from the sources, it's literally the derivative.
Essentially, yes. It quantifies how responsive the price is.
Okay.
If DPDS is big, that means the price is super sensitive. A tiny change in supply could mean a huge price swing, high sensitivity.
And if it's small?
Then the price is more stable, less sensitive to those supply fluctuations.
Okay, that helps. The sources also use this other phrase, differentiation in food security. That sounds related, but different.
Yeah, it's easy to get confused there. It probably doesn't mean the math operation itself in that context. It likely means how the sensitivity, which we measure using differentiation, actually differs. Varies across different foods or maybe different places or even different times.
Ah, I see. So, the sensitivity for rice might be different from the sensitivity for, say, avocados.
Exactly that. Or maybe the price of corn is more sensitive in one region than another. That variation is the differentiation in food security they're likely referring to.
So understanding those differences, the why behind them, is key for food security.
Absolutely. And calculus, specifically differentiation, gives us the power to actually measure and compare these sensitivities properly, rigorously.
So instead of just saying, yeah, rice seems more price volatile than potatoes.
You can say, at this supply level, the price sensitivity, DPDS, for rice is X, while for potatoes it's Y. You put a number on it.
And that's the tool you're learning in your math classes right now.
That's the power of it, taking this real-world economic idea and giving you a concrete way to analyze its impact on price stability, on food security.
It really shows how this sometimes abstract-seeming math is directly useful for understanding, critical global issues.
Definitely. You're not just learning rules, you're learning tools to measure how the world works.
So, quick recap. Differentiation helps measure that sensitivity, that immediate rate of change in price versus supply.
Exactly. It lets us quantify those differences the sources talk about regarding food security. Applying these math concepts gives us real analytical traction on economic dynamics.
It shows how the math you're learning can be directly applied.
Yeah, and maybe think about this as we wrap up. If differentiation gives us the rate of change,
Yeah.
what about integration? The opposite. How might that help understand the, let's say, total impact of price changes over time or the total effect across a whole market?
Like summing things up instead of finding the rate.
Could be. Or maybe think about other things in the world, outside economics even. What other sensitivities could the tool of differentiation help you measure and understand? Something to ponder.